Hello everyone, welcome to the ML and AI from scratch. This is episode 4 and it's a special one. That is the first hands-on episode in the series. Up until now, we have been building your mental model. What ML is, what the three types are, how the pipeline works. That foundation matters, but today we make it real. By the end of this episode, you will have a working Python ML environment on your computer. Every library installed, Jupyter running, and your first code cell executed. From episode 5 onwards, every video will include code you can run yourself. Let's get your machine ready. 5 things today. First one, why Python for machine learning. The second one, installing Anaconda. The third one, Jupyter Notebook walkthrough. And the fourth one, the core ML library. Fifth is verify your setup. Before we install anything, let's be explicit about why we are using Python, because this is a question worth answering properly. The first one, the honest answer is the entire machine learning ecosystem choose Python, and that choice has compounded for 15 years. TensorFlow, PyTorch, scikit-learn, Keras, Hugging Face transformers. Every machine learning framework is Python first, not Python compatible, Python first. That means the documentation is in Python, the examples are in Python, the community answers questions in Python. Beyond the ecosystem, Python has another major advantages for learners. Its syntax gets out of your way. When you are trying to understand why gradient doesn't work, you don't want to also wrestle with semicolons and type declarations. Python reads almost like pseudocode. And practically every machine learning job you will ever apply for will list Python as a requirement. This is not a preference, it's the language of the field. The most common setup mistake beginners make is installing Python alone and then trying to install each library one at a time, fighting version conflicts and broken dependency. We are going to avoid all of that. Instead, we all use Anaconda, a Python distribution that comes pre-packaged with over 250 data science libraries and a package manager called Conda. One installer and you are done. Here's where to go. Go to anaconda.com/download. Choose your operating system, Windows, Mac OS or Linux. Download the individual edition, which is completely free. Make sure you pick the 64-bit installer and run the installer. Accept all the default settings. On Windows specifically, when you see the option to add Anaconda to path, check it. This lets you use Conda from any terminal window. Once it's installed, open your terminal or command prompt and type Conda version. If you see a version number come back, installation worked. If you already have Python installed on your machine, that's completely fine. Anaconda will install alongside it without conflict. Now let's talk about where you will actually be writing code through this course. Jupyter Notebook. Jupyter is an interactive coding environment that runs in your web browser. Instead of writing a script and running the whole thing at once, you work in cells. Each cell holds a small block of code. You run one cell at a time, see the output immediately below it, and move on to the next. This is ideal for learning machine learning. You can load your data, inspect it, clean it, train a model, evaluate it, all as a separate visible steps. If something goes wrong, you can fix just that cell and rerun it. You can launch Jupyter 3 ways. From Anaconda Navigator, open it, find Jupyter Notebook and click launch. From the terminal, type Jupyter Notebook, or if you prefer VS Code, install the Jupyter extension and open any .ipynb file. Your browser will open a file free. Click New Python 3 to create your first notebook. You will see an empty cell. That's where we start. One note: Jupyter Lab is the newer, more full-featured version of Jupyter. Either works perfectly for this course. Every machine learning project in Python uses the same 4 foundational libraries. You need to understand what each one does before you use it. The first one is NumPy, numerical computing. This is the bedrock. NumPy gives you fast arrays and matrix operations. Every other library, pandas, scikit-learn, TensorFlow, stores data as NumPy arrays under the hood. When your model takes in data, is taking in NumPy arrays. You will use it in constantly, often without realizing it. And the second one is pandas. This for data manipulation. This is your data workhorse. Pandas lets you load CSV files, Excel sheet, SQL tables, anything tabular into a structure called a data frame. Think of it as a programmable spreadsheet. You will use pandas to load your dataset, explore them, and clean them in every project. And the third one is matplotlib. It is for data visualization. Before you train any model, you should always look at your data. Matplotlib creates charts, scatter plots, histograms, and line graph. Understanding the shape of your data before modeling catches problems early and saves enormous time. And the fourth one is scikit-learn. It is a machine learning library. This is where the actual algorithms live. Linear regression, decision trees, random forest, SVMs, K-means, all of them with a clean, consistent API. You will use scikit-learn for almost every model in phases 1 and 2 of this course. Now let's verify the setup. Open a fresh Jupyter Notebook. Create a new cell. Type exactly what you see on screen, the 4 import statement and 3 print lines. Run the cell with Shift plus Enter. If you see version numbers printed for NumPy, pandas and scikit-learn, your environment is fully working. That's your green light. On the right side of this slide, I have listed the 4 most common errors you might hit and exactly how to fix each one. If you get module not found error, open a terminal and run conda install and the library name. If the Jupyter kernel will not start, go to the kernel in the menu and choose restart. If conda is not found in your terminal, close the terminal completely and reopen it. The path update only takes effect in a new session. And if you are on the wrong Python version, create a fresh environment with conda, create an ML Python and the version of that Python, that is 3.11. Now pause the video here if you need to. Don't move to the episode 5 until this cell runs clean. Once your setup is verified, try this second cell. It creates a tiny dataset and plots it. 5 lines of NumPy and NumPy to create 2 arrays, your x and y values. 4 lines of matplotlib to scatter plot them with the title and axis labels. This is not a machine learning model yet, but it's the exact shape of what every machine learning project starts with. Create data, look at it, understand it. The model comes after that. 2 things to notice here. First, np.array. This is how you create the data structure that every machine learning model will expect as input. Get comfortable with it early. And the second one is plt.scatter. This is the habit every good machine learning practitioner has. Visualize before you model always. Now look at the cheat sheet. Here's a reference slide work bookmarking the commands you will use most in your first week. The left column is Conda, creating environments, activating them, installing packages, listing what's installed. The middle one is Jupyter, launching it, running cells, inserting new cells. And right column is pip, the alternative package manager, useful for package not available through Conda. You don't need to memorize these, just know they exist and come back to this slide when you need them. That's all. So, what's coming next? In episode 5 is your first real machine learning model, linear regression. Theory first, then live code in Jupyter on a actual sheet. You will train a model that predicts house prices. And episode 6 is all about data, loading, exploring and visualizing dataset with pandas and matplotlib before we touch any model. And the episode 7 covers evaluation, train test splits, overfitting and the metrics that tell you if your model is actually good. Yeah, that's all for today. You are set up, you are ready. From this episode onwards, every video includes a real runnable code. That's a promise. Open your notebook, follow along, run the cells. Machine learning is a skill you build by doing, not just watching. One thing I would love to say, drop a command with the screenshot of your setup working. It's a small thing, but it marks the moment you went from watching machine learning videos to actual doing machine learning. That distinction matters. Subscribe if you haven't already. Episode 5 is where we train our first model together. I will see you there. Thank you all.